We're excited to announce that our very own podcasting platform, Zencastr, has become a new sponsor to the show. Check out the podcast's discount link in our show notes and stay tuned for why we love using Zen for the podcast.
You're listening to the Archaeology Podcast Network.
Hello and welcome to the Archaeotech Podcast, episode 126. I'm your host, Chris Webster, with my co-host, Paul Zimmerman. Today we talk to Dr. Matthew Harpster about modeling concentrations of maritime activity in the past. Let's get to it. Dr. Harpster received his PhD in anthropology with a specialty in nautical archaeology from Texas A&M University in 2005. Following a postdoc at MIT in 2006, he was living and working in northern Cyprus until 2013, when he was awarded a 2-year research post as a Marie Curie Fellow at the University of Birmingham, England. Since 2016, Dr. Harpster has been living and working in Istanbul, Turkey, at Koç University, where he is an assistant professor in the Department of Archaeology and History of Art and the director of Koç University Mustafa V. Koç Maritime Archaeology Research Center. Welcome back to the show, everybody, and welcome, Paul. How's it going?
I'm doing all right today. Still sheltering in. How are you doing, Chris?
Not too bad. Yeah, Nevada, as we're recording this, was one of the last states. I think there's still a few holdouts, but one of the last states to have an official shelter-in-place order during this crazy time. So we've gone out, I think, once, maybe twice a week to head over to my office and check mail, and we're having grocery and food delivered and stuff like that. It's a weird time, but hey, you know what doesn't stop? Podcasting.
No, a lot of podcasts lately.
That's right. That's right. Although I did hear that there's been a decrease in podcast listenership because a lot of people listen on their commutes to work and during workouts and stuff like that. And a lot of people don't have home gym equipment. So their workouts are suffering, and probably gyms are going to see a New Year's Eve style resurgence in memberships when all this is over. But also people are going to work. So they're watching a lot more TV and not listening to podcasts. So I don't know if our audience is doing the same thing, but I've definitely heard that.
We'll be curious to see the numbers afterwards.
Yeah, exactly. So, but anyway, we are continuing on, and we have another great interview for you today, and we're going to bring him on right now. So Matthew Harpster, welcome to the show.
Thank you very much. I appreciate you being here.
Yeah, no problem. So we gave your bio in the beginning of the show, but why don't you tell us a little bit about what we're talking about today? There's a paper in the Journal of Archaeological Science. We'll start with that, and then give us the nuts and bolts of what that's about.
Well, the basic idea of the paper, and I was very lucky to do this as a Marie Curie Fellow at the University of Birmingham in England. The basic idea of the paper was that many people doing maritime archaeology have tried to use maritime archaeological data to try and understand movements in antiquity. How did people move around the sea? Where did they go? And can we find patterns in all that? And what I tried to do in the paper is make a contrast to the other efforts that people are making. So most of the other efforts, they might try and use vectors and create specific routes. So for example, someone is sailing from Alexandria along the Levantine coast, and then they go along the southern coastline of Turkey and find their way to the Aegean. But from my perspective, it's kind of hard to come up with those routes with archaeological data because there's so many variables. So what my co-author and I tried to do, and my co-author is Henry Chapman, and he's the one that really taught me the GIS, is we tried to kind of embrace all those variables. Rather than saying, well, it's more likely here and less likely there, we simply used all the archaeological data in a single assemblage to come up with a broad polygon of where a single ship may have been sailing around. And so the idea is that the ship could have been operating anywhere within that single polygon. And once we kind of established that idea, it simply meant that we could superimpose more and more and more of these polygons based upon the large data set of information in the Mediterranean. And once we have superimposed all these polygons, we could see where there's a higher density of polygons and then a lower density of polygons. And in turn, that would give us ideas of where there may have been more activity or less activity. And then if we can, if we can segregate this data by century, we can see where these different densities of activity may be moving and flowing around the Mediterranean. So in a nutshell, that's really what we tried to do in the article. And it's nice to explain it in about a minute and a half because it took us like 4 years to actually work it out.
Right.
Yeah.
So segregated by century, what time span are you looking at here?
Well, we're lucky because working in the Mediterranean, we've got loads and loads of maritime archaeological data. So our data set runs from about the 7th century BC all the way to the 7th century AD.
So it sounds like to me that what you ended up possibly mapping were, for lack of a better phrase, like shipping lanes and things like that at different times, probably corresponding to the different rises and ebbs and flows of cities and port areas around the Mediterranean, right?
You could say that, yeah. I mean, I'd like to think of it more as like areas of activity, you could say, with a higher density of activity, say, off the North African coast, and a lower density of activity off Italy at the same time. Because, I mean, even today, if a ship is going to sail across the Atlantic, they're not going to follow a very, very specific route. They're going to have to veer or wander here and there, depending upon how the weather changes. So the same thing was happening in antiquity. So it's not specifically a route as much as it is just an area in which the activity was happening. But the point that you made, that we can compare this to certain cities, certain regions, it's really there, and it's very much fun. We could look at how the movement of the capital of Rome from the city of Rome to Constantinople, we could see how that might impact all these densities of activity, for example.
What prompted the approach that you guys used in this paper? Because it seems to me like, man, of all the things that we know in the world from an archaeological standpoint, it seems like we know a whole heck of a lot about the Mediterranean because it's been around for a long time.
Yeah.
So where was the motivation behind doing this?
It's funny because how can I say, knowing that this podcast was coming, I've been trying to work out an answer for that, and there's no simple answer to it. Honestly, I mean, I wish I had like a simple answer. In a way, it's kind of like, well, you mentioned in my bio that I was living and working in northern Cyprus, and I was there for 7 years. And for part of that time, in a way, I literally found myself very isolated from the rest of the archaeological community. And so I think that kind of forced me to look at it and the way we're doing maritime archaeology as an outsider. And then I kind of coupled that with the fact that I was teaching a lot of method and theory. So I started to really dig into the way that maritime archaeologists do their job. Like, why do we do this? Why do we do that? How do we come up with these answers? And so I think I was deconstructing things a lot. And I started to wonder, well, why do we always do it like this? Why are we always trying to create a route when we know we can't really predict it that well? And so I think that was a big part of it, really.
Okay.
So obviously, Mediterranean is a major interaction sphere for centuries, for millennia. In fact, this is outside of the time period that you're looking at, but a very famous shipwreck off the coast of Turkey, and you're based off of Turkey now, out of Turkey now, is the Uluburun shipwreck, which anytime I teach ancient Near Eastern archaeology, I always touch on that because in that one shipwreck, you've got goods that are from all over the Eastern Mediterranean and Western Asia.
Yeah.
Is that what you're looking at? Is these ships that have goods from multiple locations to try to map sources and destinations of goods?
Well, I guess there's a couple of ways to answer that. I mean, in a very straightforward way, that's precisely what we're looking at. So with Uluburun, for example, there's material from Egypt, the Levantine coast, Syria-Palestine, Anatolia, Cyprus, so on and so forth. And so with that single example, when we're thinking about the polygon, we would put a point at each of those sources of the material in the shipwreck. So Cyprus, say Alexandria, places in the Syro-Palestine coastline, and then somewhere in Anatolia. And we try and be as exact as we can with those particular source points. And then the very last point would be where the ship sinks. And then by combining all those points, we're able to create that polygon. And that roughly represents where we think, or where we're proposing, the ship was operating. But what I also try and do in this work is that archaeologists in the past, they would commonly try and segregate the material they're looking at. So for example, they might only look at the cargo to determine the route the ship has taken. But again, that doesn't really work. The cargo could change every 2 or 3 times the ship lands on a shore. So you might only have the most recent information. So what we're trying to do in this project is we're trying to look at everything that's in the assemblage as much as we can. So cargo, personal items, it could be ship's equipment. As long as the reports can tell us where the amphora comes from, or where the oil lamp, or where even the wood comes from, that becomes a source point within the polygon that we're building. So hopefully we can create extraordinarily detailed polygons as long as the reported information becomes more and more accurate.
Mm-hmm.
Does that make, I'm unsure if that makes sense. It's kind of hard to explain it without having all the drawings.
No, it certainly does.
Okay.
And you're looking at aggregated data amongst numerous different shipwrecks, apparently. So how many different shipwrecks were you looking at? And were you looking at things other than just shipwrecks, other kinds of traces of human activity across the Mediterranean Sea?
Well, let's see. When I first started working this out, I think I had about 400 or so assemblages within the data set. And at this point, I have, say, just over 1,000 assemblages within the data set. So there's a lot of data to play with. But I think another thing to consider is that although a lot of the publications that we put out as maritime archaeologists, we talk about shipwrecks and this many shipwrecks and that many shipwrecks, the big secret is that we really don't have a good definition of a shipwreck yet.
Really?
So there's lots of online data sets that you can find. There's ones at Oxford and University of North Carolina. There's one at Harvard. And they have these online data sets of here are all the shipwrecks in the Mediterranean during the late medieval period. But the trick is that we don't really know that all those assemblages are shipwrecks. They could be jettison. It could just be stuff on the seabed. So what I'm trying to do in this data set is I'm trying to look at as many assemblages as I can, not just things that are specifically shipwrecks, because we can't really distinguish if it is or isn't a shipwreck. So it's easier for me just to find material in peer-reviewed journals and simply use it as an assemblage.
Speaking of your data set, this is something I've been wondering as you've been speaking about this and mentioning the different things you're using. I was definitely thinking about shipwrecks, obviously, and then I wasn't thinking about things that are like non-shipwrecks, but somehow, assemblages that are cargo, things like that. But what about other sets of data that you may have brought in here, like port records and anything written records from the ports that we have of when ships, appeared different places? I don't know. Journal entries. Do we have any weather data from I don't know if cores or anything have been taken from anywhere in the Mediterranean that would give us any sense of weather data, which would indicate possible big weather events that would cause shipping to change or something like that? That might be stretching it a bit, but what other kinds of data are you bringing in besides these?
There's a load of good questions there. I mean, we could talk about this for hours if you gave me a chance. Let me think. Well,
Please.
In terms of other types of data, I mean, another thing that I'm trying to do within this project is that maybe I'm just being a contrarian. I don't really know. Again, when people are commonly trying to understand movement, maritime movement on the Mediterranean in antiquity, they're using this approach that pulls in all these different types of data. So they'll have archaeological material. And if it's, for example, a Roman period ship, then they'll look at textual sources to understand where the ships may have been going. They'll use pictorial information to get an idea of what the ships look like. And one of the approaches I'm taking, as I said, I must be a contrarian, I don't know why I thought of this, is that now that we have so many assemblages in the Mediterranean to work with, we have such a big coherent data set, what if we use this archaeological data entirely on its own? What if we just look at this archaeological material in isolation from the textual or the pictorial information and just see what sort of narratives it generates? Does it give us information that complements these other sources, or does it give us information that's radically different? And so that's kind of another goal or another path I'm following, is to really see, now that we're generating these narratives and we can see how these concentrations of movement shift from one part of the sea to the other, does that match what the textual sources are saying or not?
So your example earlier was about the capital of Rome moving from Rome proper to Constantinople. That one would expect would manifest with different changes in trade patterns. Are you generally finding confirmation of what you're expecting to find, or are you finding things that don't quite match what you're expecting?
Well, in some cases, we're finding both. The example of the capital of the Roman Empire, going to Constantinople, we do see a nice shift in the highest densities of activity. So predictably, previously, most of it was in the Western Med. And then after that, by the 4th, 5th, 6th century, it tends to move eastwards. So we're seeing things like that. Similarly, in the Roman imperial period, from about the 1st to about the 3rd century AD, there's a much higher concentration of activity on the North African coast. So in some cases, we're seeing broad patterns that do match what we're expecting to find. And of course, that makes me nervous that perhaps I'm just like illustrating what I think should be there. But what we're also finding are some interesting patterns that I didn't expect. So, for example, if you look at the terrestrial archaeological record in Israel, for example, there's a fairly healthy collection of amphora there that come from Spain. But yet, when we look at the maritime record, we don't seem to be finding any amphorae from Spain underwater. So what's happening there? Why is this occurring?
Presumably they're not traveling overland.
Yeah, theoretically, that would be quite the trip. But we're not really sure what's happening. I mean, one possibility is that there was an author from the UK, is an author from the UK named A.J. Parker, and he worked with a lot of big data sets of wrecks in the Mediterranean. And he's proposed that we can kind of see this pattern of distribution of material across the Mediterranean that tends to step down in these nice graduated amounts, so that material that's very close to its source, you're going to see a whole lot of it. And predictably, it just drops down more and more the farther you get from the source. So if we have material from Spain, for example, there's a whole lot in the west and there's very little in the east. But what he proposes is that it doesn't decrease in a nice gradual fashion. It tends to decrease in these major drops from one point to another, as if like 30% of the amount of material just drops out of circulation. So one of the theories I have when we're talking about this weird phenomena in Israel is that perhaps the amount of Spanish amphorae coming or making its way all the way to that coastline was very, very small. Perhaps in one ship, there might only be 2 or 3. So by the time they get there, they're not just a boring cargo. It's more of a luxury item. It's more of an exotic thing. Mm-hmm. So it's possible that once they get that far away from home, they're treasured and valued much more than they would be, say, in Spain. So they're not underwater because there's so few to start with. But then we're finding them on land because they're being preserved on purpose, because they're representing this exotic luxury good. But that's really just a shot in the dark. That may be it, or it may not be. And again, maybe our data set is incorrect. Maybe there's a whole lot of Spanish amphorae underwater. We just haven't seen it.
Great. Well, why don't we take a little break here, and we'll continue this conversation in just a couple minutes, and ask you some more questions about what you're seeing in the data sets of these submerged archaeological assemblages.
Chris Webster here for the Archaeology Podcast Network. We strive for high-quality interviews and content so you can find information on any topic in archaeology from around the world. One way we do that is by recording interviews with our hosts and guests located in many parts of the world all at once. We do that through the use of Zencastr. That's Zencastr. Zencastr allows us to record high-quality audio with no stress on the guest. Just send them a link to click on, and that's it. Zencastr does the rest. They even do automatic transcriptions. Check out the link in the show notes for 30% off your first 3 months, or go to zencastr.com and use the code Archaeotech. That's ARCHAEOTECH. Looking to expand your knowledge of X-rays and imaging in the archaeology field? Then check out An Introduction to Paleoradiography, a short online course offering professional training for archaeologists and affiliated disciplines. Created by archaeologist, radiographer, and lecturer James Elliott, the content of this course is based upon his research and teaching experience in higher education. It is approved by the Chartered Institute for Archaeologists as 4 hours of training. That's in the UK, for those of you that don't know. So don't miss out on this exciting opportunity for professional and personal development. For more information on pricing and course structure, visit paleoimaging.com. That's PALEO imaging.com, and look for the link in the show notes to this episode.
Hi, Hi, welcome back to the Archaeotech Podcast, episode number 126. We're resuming our conversation with Dr. Matthew Harpster about the work that he had done in the Mediterranean with shipwrecks and looking at patterns of transmission of goods and the like. You use GIS very heavily in your project, and I was wondering if maybe we want to approach that topic a little bit. What kind of GIS were you doing, and how were you importing these data into it?
I mean, well, you're right. I mean, GIS is essential to this project. I mean, the very earliest attempt I had with this, like I had an idea in my head of what to do, but I didn't really know that GIS existed. So I just did it all in Photoshop the first time. And the results honestly worked, but it's like, it was so incredibly tedious. And if it was a program on my computer, if the thing crashed, all the data disappeared. So yeah, GIS is essential to what I'm doing. And I've been lucky that I've been able to use it. And as I mentioned, my co-author, Henry Chapman, at the University of Birmingham, he's the one that taught me GIS. So a great deal of the credit goes to him as well. He was patient enough to teach me how to do it. So we're using GIS, obviously, because it allows us to play with all of this spatial data. And so on the one hand, as I mentioned, we're generating these polygons. So each polygon that represents where the ship is operating, that's a single shape file within the GIS program. And we're using ArcGIS, by the way. So that becomes tedious on its own because, as I said, we have a data set of well over 1,000 assemblages. So that means that I have 1,000 shape files with one polygon in each file.
Jeez.
So on the one hand, that becomes rather tedious in terms of management. But on the other hand, it allows us to really select which shipwrecks or which assemblages we want to look at. So I could pull out all the polygons that represent data from the 2nd century BC, and then I could look at the patterns. Or alternatively, I could look at all the polygons that represent ships that are built in a certain way, because ships in the Mediterranean in antiquity, they were built in 2 or 3 different methods. So I might find that ships' hulls that are built in one way, they create this one pattern across the Mediterranean, but a different type of ship, it's giving us a very different pattern. So on the one hand, it becomes rather tedious in terms of management because we have all these shape files, one for each shipwreck. And then on top of that, for me, the most tedious part was coming up with a way to color code all of the polygons. Because one of the ways we're able to distinguish not only concentrations or densities of movement, but we're also able to distinguish if the ship, for example, only has material from the Western Mediterranean, then we color code the polygon as being red. And then once we have all these red polygons piled up, we can basically make a heat map of the polygons and find out where the highest density is. And then that simply shows up as red on the resulting map. But we can use blue for material from the Aegean. We can use green for the Eastern Med. We can use polygons that are color-coded as black for the Adriatic. And so once we have all these different colors, we can see on the one hand how concentrations and densities of movement are shifting east and west or north and south, but we can also see what in particular is moving. And if it's homogeneous cargoes only from the Adriatic, or if it's mixtures of stuff from the Aegean and Eastern Med. So that was really a very tedious part of working with GIS, because for a long time I had to get into the raw guts of the color palette and figure out how to combine the colors in certain ways and how to code that for a particular polygon. And then unexpectedly, we ran into a problem in that the most recent version of GIS we had until about 3 years ago, I think it was ArcGIS 10.14 or something like that. I may be getting the names wrong. But we were able to color code all the polygons with the correct colors, but then we couldn't make a heat map that would actually reflect all the different colors, because the heat map would only work in one color, like blue or only red. So it's only the most recent version of ArcGIS, it's called GIS Pro, that we're actually able to do everything we kind of envisioned with all of this. So for me, it was one of those weird instances in which technology kind of had to catch up with what we were trying to do archaeologically, when in my experience, it's usually the other way around.
Mm-hmm.
I can send you the PDF of the article and you'll see the heat maps with all the real nuts and bolts of the GIS in the article.
Well, that'd be great.
That'd be wonderful.
Yeah, that'd be really good. So taking a look at all this data and what you guys are able to see from it, and just looking at the abstract for the article and saying how you're able to understand some more about the Mediterranean and these different maritime activities, has there been any other confirmation of what you guys are doing by people actually finding shipwrecks or other evidence of submerged maritime activity based on some of the stuff you guys are finding in some of the areas that you're defining?
No, it's a good question. And that's involved in sort of bigger plans that I hope to pursue in some way. On the one hand, by getting the article out there, and then I obviously hope to keep doing more with this idea, is that people take this and then they test it. So clearly, I'm proposing a theory. I'm proposing a model. This is how this works based upon the archaeological data set. So someone in Spain, for example, could look at the model, and according to the model, this sort of activity with this sort of material data should be off the coastline. But it means that an archaeologist in Spain could then look at their survey data that hasn't been published, and maybe it reinforces our model, or maybe it contradicts it. So in a way, that's really what I'm looking forward to, is when we start to get to that point, when people can compare what we're proposing against the raw data they have. So hopefully that will happen, I don't know, in the next couple of years, once I get more of this information out. I mean, we're trying to do some field work on our own that's also going to test these ideas. So we'll see how that goes as well. That's been happening off Italy. And we're just crossing our fingers that, what we think is happening will actually be reflected in the data we find on the seabed.
Can you explain a little bit how you plan to go about doing that?
Well, we started doing surveys there about 5 years ago. And the goal at the time was really to do two things. On the one hand, the goal was to survey part of the coastline. And luckily, we're working on the coastline between Salerno and Punta Campanella. So right there along the Amalfi coastline of the peninsula. And the original idea was to do two things, was to try and do this maritime landscape survey of the area to understand what this region was like really during the first millennium AD. Because when we look at other historical records, everything seems to be going well. Then Vesuvius erupts, and it's like nothing happens for 1,000 years, and then suddenly everyone's moving around again. So that was one part of what we wanted to do, is, try and fill in that gap archaeologically. But the other was to test these models that we're creating. Because based upon the models we're creating with, that you have in the article, it appears that either this particular peninsula or the Bay of Naples just to the north, it appears that this area represents some sort of strange gradient in the data we're collecting. So as material from the Aegean and the Eastern Med is moving westwards, it will go by Sicily, it'll come northwards, and it will reach this part of the Italian coastline. And then it seems like it doesn't go any farther north. It appears that once it gets to this point, probably the Bay of Naples, it just moves inland and then it's distributed on land for the rest of its journey to the Western Med. Whereas our data indicates that farther north of the Bay of Naples, most of the activity is really localized. It's all stuff from the Western Med, from Italy, France, Spain, as well as ports in North Africa. So the second thing we've been trying to do in this survey is to collect raw field data right along this survey area and to see if this raw field data reinforces what these models are suggesting.
Wow, that's really cool. It's amazing to see where this research could go in the future. I have visions while you were talking about this, adding more data to it, and then just having a computer program say, hey, go look here. I think there's something here. And,
that'd
and
be
just,
fun.
and having there be something there. I I don't think we're far off from that. To be honest, we've talked to a number of different people on this podcast that are putting together either machine learning algorithms to identify things on the landscape or doing what you're doing by cramming in a whole bunch of data and really coming up with some solid potential answers, or at least hotspots, places to look for things. I think man, if we could just bring all these different lines of research together, it would be amazing in its own right.
That would be fun. I'd like to meet the people that are doing the machine learning, because that's far above my head. There's no way I'm going to get near that.
Yeah, the secret is it's far above ours too.
And that's why it's really cool, because we all learn new things on this podcast. And that's one of the things I love about doing this. And I'll tell you what, one of the guys doing the machine learning algorithms for pottery was actually, and Paul, correct me if I'm wrong, I think that's over in Greece, is it not? And
I thought he was doing it
we
in
just
Spain,
interviewed them.
No?
Oh, you might be right. I think it was in Spain.
Okay.
But we interviewed them just a few months ago. But anyway, looking at as we approach the end of this section, looking at this, where are you going from here? Because you've mentioned already that you're continuing to do this research, continuing to do these things. If you're at a university, how are you involving your students and your classes and continuing this line of research?
Well, let's see. I mean, one of the ideas is that I would love to, as I mentioned previously, it'd be nice to have other archaeologists in the field test this against their raw data. So one of the ideas I'm playing with the IT services on campus is if there's a way to put our current models, on the internet somewhere, like on our departmental website. And then, because we simply have a big data set, there should be a way in which the public could go to these models and then they simply choose, like, show me the 2nd century AD, or show me all of the data from this particular part of the Mediterranean, or show me all the data that has this particular type of material on board. But I think what would be particularly nice is if there's a way that someone, again, in Spain, could go to the website and then they could actually superimpose another polygon based upon the data they have over the material we already have. So they're simply adding to our data set. And then once they do that, it could be integrated into our modeling and we could see how the model changes. So in a way, that's an idealized thing. And I would love to see that happen. But again, this is far above my pay grade and my skill set. So I don't know if it'll ever happen. Something in my brain tells me it would work, but that doesn't always mean it's good.
No, it's exciting. I'm already envisioning looking at major commodities like oil or copper ingots or something like that, and looking at their distribution, their change through time, and then mapping that back against political and environmental changes.
Yeah. What if you're looking at the distribution of copper and there isn't any change in relationship to political shifts on land?
That would be interesting too.
Yeah.
Yeah. Well, speaking of that, what are some other big questions that you would like to answer through these data that you haven't answered yet? Like maybe you're missing maybe there is a data set that you need and somebody listening to this podcast has the data set that they can add to what you have to help answer some of those questions.
Oh, that's a good one. Well, I need more data from the Western Mediterranean, basically after the 3rd century AD. Like, for some reason, among the journals I've looked through, among the data we've collected, like the late Roman, Byzantine eras in the Western Med are just really poorly represented. I don't know what's going on there. So that's a big gap we have to fill in. And I guess as people look at the article and they listen to this podcast, that's something to keep in mind, is that the data set I have isn't perfect. It's not evenly distributed chronologically across the Mediterranean. So that's one thing we still need to work on, is to fill in these gaps with the data. But the other thing I'd really like to see is that since we've basically built up this methodology for determining these shifts in activity, what would happen if we took this and then we brought it to another body of water elsewhere in the world? What if we brought it to the Indian Ocean or the Atlantic Ocean, and then we tried to put in all the archaeological data for that? What would that tell us? And can we do it? Is this methodology, does it only work in the Mediterranean, or does it work at any body of water? And then beyond that, can we scale it down? What if we put it in the Black Sea? What if we put it in a lake or a river? If the density of data is enough, can we see similar ebbs and flows and changes in the density of movement? I don't really know. I mean, these are just ideas that are floating out there to play with for the next 10 years. So hopefully I'll be able to.
Well, what if this model is just even more broad than that? I mean, what about dropping it on a country or a region and putting in similar types of things? You know, why limit it to water? I mean, if it's a similar, the thought process seems to be a model that could be used for a number of applications, and just entering in those parameters for whatever thing that you're talking about could produce similar results.
I think it could. And that's something I've wondered about. I mean, the one thing we can do on land that we have more trouble with working on the Mediterranean Sea is that we can more easily integrate, least cost path analyses when we're dealing with movement on land.
Right.
Oh, yeah.
And if there's a way to integrate that into the way that the polygon is being portrayed, into the way it's color coded, then you're right. We could just start superimposing all kinds of things. And who knows what's going to come up. I actually got an email from a scholar in Iran, I think last week. They saw this article and they want to see if there's a way to apply this to the distribution of Zoroastrian temples across Iran.
Nice.
I don't really know, but we'll give it a shot. We'll see what happens.
I've got all sorts of ideas now. I'm wondering about the applicability on land compared to in the sea, because, seagoing is in vessels. So you have, an assemblage is presumably a group of items that we're all traveling together, as opposed to, if you have trade goods found on land, there, you don't necessarily, it's not a sunk ship, for example, that dropped them all in one place. I don't even know where I'm going with that, but that just seems to me like a difference in the way the transportation works. And then I'm thinking of different transportation. You kind of hint at it before. And since my expertise with trade is the Arabian Sea, there definitely are different modes of transportation that have different associated goods, the smaller kinds of ships that just coast versus the bigger later ones that would, go between Arabia and India with the monsoons. And holy cow. I'm afraid if I read your article, I'm going to go down a rabbit hole thinking about ways that we could try to analyze those data sets.
Yeah, well, let me know what you think of. And I mean, I guess, ironically, the idea of bringing it back to the land would, how can I put it? It would create an interesting scenario, because fundamentally, these polygons that we're developing from the assemblages on the seabed, these polygons are basically it's just site catchment analysis. That's really all we're doing when we look at the assemblage on the seabed. I mean, I know you guys have done CRM work. You both have backgrounds in archaeology. So this is just site catchment analysis, except we're simply making the assumption that the resulting polygon we draw just represents the area that the ship was operating in, instead of the polygon representing where the people were moving around to collect stuff and to bring it back to their settlement. That's really the only difference.
Okay, well, I think that is a good place to end this, because, as you said earlier, we could go on for hours, and we probably will someday. But I'd love to hear, Matthew, anything you have leading from this research, or any additional research, or hey, if you do end up mapping Zoroastrian temples, let us know. We'll bring you and that other researcher on, and we'll talk about that as well. So, thank you for coming on the show. Thank you for bringing this awesome topic to us, and I hope you guys have some great results coming in the future.
I hope we do as well. And thank you for the opportunity. I really appreciate it.
Well, glad to have you. Now wash your hands.
Don't worry. Every 10 minutes around here.
That's our new sign off.
Be safe.
You may have heard my pitch for membership. It's a great idea and really helps out. However, you can also support us by picking up a fun t-shirt, sticker, or something from a large selection of items from our TeePublic store. Head over to arcpodnet.com/shop for a link. That's arcpodnet.com/shop to pick up some fun swag and support the show.
When you need mealtime inspiration, it's worth shopping Baker's, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Baker's worth it every time. Baker's, fresh for everyone. Fuel restrictions apply.
All right, welcome back to the Archaeotech Podcast, episode 126. And Paul and I are going to wrap up that fantastic interview we just had with Dr. Matthew Harpster. Man, Paul, what are your big thoughts after doing that? I mean, I've got so many things in my head right now that he just generated.
Yeah, no, I'm really excited about it. I mean, I always like notions of trade and how we can map them. And again, I mentioned in the last segment that, the only expertise I really have with this is trade in Arabia and along the Arabian coast. And geez, I really want to dig into this a little bit more and explore it a bit. And one thing that we didn't actually mention here, but let's mention now, is that on the link to the article, or actually on the page of the article, there is a data set that's downloadable. And so I'm going to download that and play with it in GIS myself to see if I can kind of get a better sense hands-on of what he was doing with the Mediterranean data set, because this looks like a useful way of approaching certain kinds of archaeological assemblages. What do you think?
That'd be really cool. And I think this really is where it's at. It had me thinking about like where the big picture of all this is, because everybody that you talk to, well, everybody we talk to on this podcast just about is doing some kind of modeling, right? Yeah. And they're all kind of coming up with their own ways to do it, really their own data sets to put in there, their own ideas on how to put it in. But the modeling itself, they're really all producing the same types of results. Where did things happen, and what were those things that happened? I mean, that's the big question we all have about archaeology, right? Is there right there? And that's exactly what he's trying to find. Exactly. And if we could take all of these that are coming out in the last few years, because it seems to really be, I mean, we've been doing this for decades, but just recently it seems like we're really getting some great modeling out there. We've got the computer power to take massive data sets and produce results. And, we've got satellite imagery, we've got all kinds of things. And putting this all together makes me really think that it would be great if we had a common resource for all this, or a common methodology for it, because you're downloading his data set and seeing what he did there. But really, I'd like to see like some sort of application that we could all download, where you download a data set into that application and it does the usual things we would expect to see. It just basically makes it a little more generic on its use, where you just pop in all these data, bam, here's your picture. It's kind of frustrating that we don't have that yet, to be honest.
Yeah. On the other hand, though, it's really interesting that, we ended up the last episode talking about the work that Tanya Paris is doing, and notice that we didn't actually talk about tech in the entire, explicitly talk about tech in the entire episode, in the entire interview. And this is highlighting for me too, again, what Dr. Harpster was saying here is that it's really becoming just kind of another tool, this GIS in this case that he was doing is, and we're kind of winging it, learning how to do it on our own, maybe doing the equivalent of spacing instead of tab stops in a Word document with our GIS, whatever that analogy would be. But it's become comfortable enough that, people, even without any, direct GIS experience, think, I've got a data set, I can model it in GIS because I'm looking at spatial data, and that's where you do that stuff. He said at the start that he tried doing it with Photoshop and then realized that no, this is just the wrong tool for the job. Yeah, I don't even know if this is, again, another one of my kind of musings that doesn't go anywhere in particular, but I do find it fascinating that so many of us being archaeologists writ large, wherever we're working, just are kind of gravitating to these data sets, even if we're not the necessarily the techiest archaeologists out there. Not data sets, I mean these tools, because we have data sets that are amenable to the tools.
You're totally right. And I just, again, I really wish we could get all these people together, because something else I was thinking of during that last segment, especially when we were asking him of other applications for this model, every single example that he had was based around maritime activities. And my first thought was, well, why do we need to stay in the water with this? Why can't we just take land-based data sets and do that? And then not only that, but let's link up the people that are doing land-based data, because one of the things his model must be showing, and again, I think we've mentioned in the recording that we didn't actually have access to the paper. We know how to find it now, and look at the show notes, and you'll have a link to the paper there, because it's behind Elsevier's paywall, but it's also somewhere else, which we'll link to that. So take a look at that. I'm interested to see, but I'm willing to bet these hotspots, they not only show areas of activity on the water, specifically the Mediterranean, but they probably highlight hotspots that are coastal, where these ships are all coming together, like obviously harbors and ports and things like that. And there's, of course, big ones that we know about, but there might be others that, I don't know, maybe were less used, but this model is showing that maybe it's more used than we thought. And then you can compare that with land-based models and say, hey, this is where these activities were coming together. And we didn't know when, but looking at these models, we now know kind of exactly what the range of time was that these things were happening. And then using those, looking on the water and the land to find more archaeological sites and more data. So it'd be nice to bring all that together.
Yeah, no, I mean, they definitely, and we were talking about maritime archaeology earlier last year. I can't remember the episode, and noted at the time kind of the fuzziness. You and I think of nautical archaeology and we think of, it's underwater. But that particular project that we were looking at back then was also kind of the blurry edges of the water. People building the boat on the land and pushing it down into the water, and people getting fish and bringing them up onto the land to dry them. Just as two examples of many that were covered in that. So I do think that this is a topic that could be tackled to try to get a better sense of these land use, the way that people interact with the land and with the water, and nexus of activities. And wow, again, I'm really excited to go play with this data set, because it looks like a lot of different things that a lot of different questions could be asked, very good questions, by looking at them.
Yeah, and speaking of other questions, I'll have to try to think back to the episode where we talked about this, but we talked to somebody about Chacoan landscapes, and I think they were doing least cost path analysis.
They were.
Yeah, and it made me think, man, that guy Matthew was totally right. How do you do that on water? Because on land, your least cost path, I mean, it's typically something that doesn't take you over a mountain or down a canyon, and it really is the straightest line that is the easiest one to take, right? That's probably going to be the path that somebody took to do something, especially over longer distances. But on the sea, especially something as big as the Mediterranean Sea, your path might be different every single time you take that journey, because of weather patterns, because of currents, because of the time of year, which again goes back to weather patterns and things like that. So there really is you would think on the sea, the least cost path would be straight line, right? And it probably is, but how many times in an old sailboat or sailing vessel can you actually take that path? Right. and then you'd have to look at that's one of the things I think we could get out of this data set too, is looking at, because when I mentioned first in the beginning of the episode, talking about trade routes and mapping those, I'm really interested in that, because that could help us really understand weather patterns. Because if you see a certain path that doesn't seem to make any sense, well, did they take this circuitous route to get from point A to point B because they were stopping in other places, because there was fishing along the way, because of what? Or is it because that's how the currents in the Mediterranean work, or that's how the prevailing winds work for those particular ships? I mean, it's so many questions that could be answered from this type of model.
Well, I'll give you an example from Arabian archaeology, is that in the first millennium BCE, most of the naval travel, most of the ship travels were smaller vessels that would coast, and they could go all along the Arabian Peninsula, up through the Persian Gulf, out to Iran, but they would coast in doing that. They'd go from one stop to the other. And then somewhere around the late 1st century BCE, somebody figured out how to use the monsoon winds. And so they started going from farther and farther, so closer to Aden, which is on the tip of the Arabian Peninsula, farther and farther out to India, across bigger, deeper waters. And they had to have bigger ships that could do that were stronger, that could withstand those winds. And there absolutely is a seasonality of it. They would go one way in one time of the year, and then the other way in the other time of the year, depending on the prevailing winds. And that was a technological change. It was, it's noted in time when people start figuring that out. And it allowed for different kinds of commodities to be carried. And, so there are a lot of different variables on that. But that does touch on that notion of least cost. Before you have the ships that can do that and the knowledge of how to harness those monsoon winds, the least cost is taking your small ship and going from, one port to the next along the coast. And then at a certain point, you can do huge hauls of goods at great, cost and peril, but you can do them across the Indian Ocean. So, there definitely would be amenable to that kind of study. And that's why I'm really excited about this, because I think I could take this methodology and move it from the Mediterranean to the Indian Ocean fairly easily. I don't know about the quality of the nautical archaeological data sets for the Arabian Sea and the Indian Ocean, though. That would be a big question for me.
Yeah, that's another way where we could help find some of that stuff, because you're right. The data sets for, I guess shipwrecks, for lack of a better word, probably aren't as complete as people would like them to be, because shipwrecks are really hard to find, especially ones that are way out to sea, right? Mm-hmm. So that might be one thing where that's why I was asking him too, where this model, the more data that we can put into this related to weather patterns and trade routes and, information that we already have, plus shipwreck knowledge that we already have. Of course, he's putting that in. But the more and more we can do that, the more we can say, well, there just really wasn't anybody over in this area pretty much ever, because why would they go there? They're business people. They're trying to get these things done. So let's just look here, 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 and here. And when we really start to nail these things down, and then of course, this all involves getting this type of academic information in the hands of people that are actually looking for these things, which I don't know if it's just academics. There's definitely treasure hunters and people like that go out and try to find these shipwrecks. So I guess take that with a grain of salt, but at least finding where these things could be and helping to build that data set even more. Because if this model leads to a series of shipwrecks that we didn't know existed because we didn't know to look in that space, and then we look in that space and we find them, the data recovered from those will just go to help refining the model on where those ships were and how they got there and things like that. So it's one thing I love about all this modeling stuff is the more information you find, it just improves the model, whether it tightens it up in one spot or loosens it up in another. It really just improves the model, and it's all good, and I love it. It's pretty great.
No, I agree that feedback loop, that positive feedback loop, is really is really interesting. Yeah, I tend to be afraid of feedback loops, but sometimes we can use them to our benefit, huh?
Yeah, indeed, and we can also use it as a way to really understand humanity better too, because I'll tell you what, on the micro scale, humans are pretty unpredictable. Like, you don't know what one person's going to do from 1 second to the next. But on a macro scale, humans are very predictable. And, from a societal standpoint, very, very predictable, I think. And I think archaeology has gone to prove that time and time again. So using that idea and then using a model like this and understanding how things happen and how humans work, man, I think the archaeological record in our lifetimes could get very predictable. And in micro areas, it is getting that way with people doing these models. But as we start hooking all this up together, man, I think our jobs as CRM archaeologists and academic archaeologists are going to be really going down to analysis, because we'll know where everything's at, right? We'll just turn on a computer program and say, where's my next site? Hey, haven't they said in like sci-fi and stuff like that, like if you or at least in, I think, quantum physics, I've heard this, if you knew the current position and speed, the current speed and direction and position of every single element or particle, elementary particle in the universe, then you could predict the future and know the past. Because if you know their speed and trajectory, you know where they're going to be at any point in time and how they're going to interact with each other. So I'm not saying we're going to get archaeological models to that point, but on the macro scale, we can get pretty close.
Okay, I'm tapping out now.
Come on. I'm just saying. And then let's just keep going, Paul. Well, we can apply this to other planets. Why not? Right? Species are species, right?
Okay, now we're going to have to bring in the Fermi paradox. This is just going to go off the rails real fast here.
Listen, I watched Picard like a month ago, and now we're rewatching Discovery because the season 3 is going to come out anytime in April here. So it's just on my brain. Oh, man. All right. Well, I think that's enough. We went off the rails with xenoarchaeology right at the last second. So I think that's probably good there. Hey, it would be great if somebody could connect through this podcast. And I would love it if somebody listening to this is a Mediterranean archaeologist and can help Dr. Matthew Harpster's data set and connect with him on that. Hopefully we'll have some, I didn't ask him, but I will ask him, and hopefully we'll have this in the show notes. We'll have his email, contact info, or at least his academia page. And you can connect with him and maybe use his data set for something else or his model for something else, and then possibly add to his model as well. So that would be great. And if you do, let us know and then come on the show and tell us about it. So that's it. I think our new sign off for all podcast, Paul's nailed it at the end of segment 2, is thanks for listening and go wash your hands.
Go wash your hands, you filthy animal.
Nice.
Thanks for listening to the Archaeotech podcast. Links to items mentioned on the show are in the show notes at www.arcpodnet.com/archaeotech. Contact us at chris@archaeologypodcastnetwork.com and paul@lugal.com. Support the show by becoming a member at arcpodnet.com/members. The music is a song called Off-Road and is license free from Apple. Thanks for listening.
This show is produced and recorded by the Archaeology Podcast Network, Chris Webster and Tristan Boyle, in Reno, Nevada, at the Reno Collective.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.arcpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.
Thanks again for listening to this episode and for supporting the Archaeology Podcast Network. If you want these shows to keep going, consider becoming a member for just $7.99 a month. That's cheaper than a venti quad eggnog latte. Go to arcpodnet.com/members for more info.